Before we go on to take a look at lower-level boundaries, let's see how the user session boundary has been implemented in Windows 7. We'll use sysinternals Suite for this presentation. Sysinternals is a suite of tools developed by Mark Russinovich. The tools are probably well known to all administrators and to other Windows system security practitioners. We'll run a program called Process Explorer. Even though the program is contained in a trusted directory, note that I still have to agree to run it. Taking a look at the program's properties, it turns out that the file is external. It comes from another computer. It's still blocked even though it's currently stored in my computer. This information has been saved. To disable the Open File Security warning, you need to unblock the program by clicking on the button you see above. The question is, where does Windows store this type of information? It's saved in an alternate file stream on an NTFS drive. Objects on NTFS drives can have multiple data streams. Alternate data streams are used exactly for this purpose, to store the origin of a file and allow a system to perceive it as a file that comes from an external site. Data streams may also be used to hide certain types of data. Coming back to our program, we'll run it with the administrator privileges. We'll later talk about the origin of the need to relaunch it and confirm the decision. Let's take a look at the processes that run under the current account, our account. The rows of these processes are by default highlighted in blue. The operating system's shell, for example Windows Explorer, is the currently highlighted process. Various processes are launched within this shell. The bottom pane contains information on the selected Explorer process. You can view, for example, the activity of the process. In this case, we can see the objects loaded by a given process. As you can see, a session has been set up for us. The identifier is 1. We're probably the first users who logged into this environment. By right-clicking on a process running in our session, you can select Properties. Let's move to the Security tab. Everything is tagged in such a way that the objects opened by a process can only be accessed by us, the current user account, a built-in system account, and a strange account with a visible seed. The 1-5-5-0 seed indicates a logging identifier. In a way, this is an additional identifier of the above user. No other accounts can interfere or tamper with the operation of the process, except for the operating system itself. We'll leave Process Explorer for a moment, but we'll return to it later. We'll run now a standard Windows tool, Windows Task Manager. Once all the user's processes are displayed, and we sort them by usernames, it turns out that we can view our processes and the processes of other users. This is possible because the program runs with administrator permissions. We have discovered first that a session defines a security boundary. But here we can see that an administrator account can cross this boundary. It's enough to right-click on, let's say, iExplorer.exe to be able to end it, which is an obvious interference with the operation of the process. The administrator crosses the boundary in an explicit and apparent manner. The last aspect of a user session boundary we'll cover is isolating session 0. To do this, we'll need a program called psexec. Let's start by launching the command line with administrator permissions. Next, go to the sysinternals folder. psexec is commonly used to launch processes on remote computers. It can allow us to gain access to a remote operating system and the command line of that system. One of the additional features offered by the tool enables running it in a different session after submitting that session's number. This is enabled by the -I switch. Let's now find out how it works. Let's run any program, for example calc.exe, in session 0. The calculator is running, but we don't see it on our screen. The isolation of the session is working. There's a new warning in the taskbar. A program running on our computer is trying to display a message, but we can't view it. The window appeared because Session 0 isolation is a feature that can only be implemented beginning with Windows 7. It wasn't available in the previous versions. All services were running before in the context of the session of a user who logged in first. This session encompasses also antivirus scanners, which are programs that run as system services. Antiviruses interact with users, display messages, warnings, etc. After the release of Windows 7, antiviruses shut down. To allow them to work, Microsoft introduced the dialog box you can see above. By clicking on View the Message, you switch in a way to a different desktop. You can see here the desktop of a user who launched Session 0, or effectively, the operating system. Let's quit the program and return to our own session. Because Session 0 doesn't show any new messages, the displayed window has also disappeared.